Hello, algebra students. Welcome to MathABILITY. That's that little bit of extra practice for students who struggle with algebra. Today, we're working on the last lesson of the algebra unit, solving inequalities. Fair warning, we're going to do a lot today, but I've got a real reason for that. Inequalities are really common on the GED math test. Plus, they introduce 4 new symbols and a couple of new wisdom principles. And so there's a lot going on, a lot for students to remember. So I want to make sure that you really have a good conception of what those symbols mean. And 2, I want you to have that lovely verbal script so that if you get lost in the symbols, you can get yourself found. Let's get started. Directions say translate each of the following statements into an inequality. Number 1 says a number P is less than 4.5. So I'm trying to say this number P has some relationship to 4.5. And what is the relationship between them? It's the less than. And there's the less than symbol. Now you might be saying, Kate, I can never remember the less than, greater than symbols. They're just way too tricky. And if that's you, remember to bust out that number line. On a traditional number line, as we go to the left, our numbers get smaller, like -1. And indeed, we see that that end of that number line there, that's the less than symbol, the one that points left. And then on the right, we get larger, right? 0, 1, 2, 3. And indeed, this arrowhead is the greater than symbol. So I needed to see P is less than 4.5, and we can see that it looks just like that arrowhead on the end of our number line. I did number 1. Why don't you try number 2 and then join me to check your work and look at 3. 2, a number R is greater than or equal to 7. All right, R is greater than, I'm going to go on the greater than side of the number line, that symbol, and then or equal to, we just put a little line underneath 7. Number 3, Lainey is younger than 16. No, I didn't say lesser. No, I didn't say greater. However, I can say, Lainey, let's call her L, shall we? And if I want to say she's younger than 16, that means her age is less than 16. I tried 3, you try 4. Come back and check your work with me and then move on to 5. 4, Zetia must write more than 7 pages per day to finish her book by the deadline. Oh man, Zetia, do I feel ya? Okay, let's see. She's got to write more than 7 pages. Okay, so the number of pages that Zetia writes has got to be more than 7 pages per day to finish her book by the deadline. Wonderful. Number 5, Fausto is taller than his cousin Ronnie. Now, guys, it actually doesn't really matter what letters you use, but I'm just wanting to be clear. So let's call Fausto's height F and Ronnie's height R. So Fausto and Ronnie, well, their heights are in relationship, and whose is greater? Well, Fausto is taller, and so Fausto is greater than Ronnie. 6, Nadia must smoke at least 40 pounds of salmon to be prepared for winter. Okay, underline this, highlight it, write it in your notes. This is the one that students struggle with. We'll call her Nadia. She's in relationship, well, it's her salmon that's in relationship to 40 pounds. Now, at least 40 pounds. Let's think about what that means, because a lot of students just want to automatically put a less than symbol. But if you want at least 40 pounds, that means it's okay for you to be equal to 40 pounds, but it's also okay for you to be greater than. You don't want to be less than 40 pounds if you want at least 40 pounds. That's the smallest you're allowed to be. And so at least is a greater than or equal to symbol. This is a tricky one for students, so take note of that. 7, Boniface must weigh between 150 and 165 to wrestle in his division. Now, you're not going to have to work with this kind of inequality today, but I just want you to see it. Look at this language. It says between. So Boniface, his weight has got to be between 2 numbers. What 2 numbers is it got to be between 150 and 165? Now, whenever you do these between ones, you do it in order from least to greatest. So you can see I have 150, then Boniface's weight, then 165. And you use either less than or equal to symbols because of that whole least to greatest thing. Let's see, he must weigh between 150. Is it okay for him to be 150? Yes. And 165. Looks like he could be 165 as well. And so I'll use less than or equal to signs because the two endpoints are acceptable weights. Let's try a visual representation with these symbols. Directions say refer to the number line to fill in the blank and complete each inequality. Take a look at this number line here. There's no numbers on it, right? I don't know if A is 5 or 500 or -11, but I can see where A is in relationship to the other points, and that's what we're going to use here. And let's just assume this is a standard number line with the numbers getting less than as we go out to the left and greater than as we go out to the right. I'm not trying to trick you. I'm just trying to orient you around our standard number line. So the relationship between A and D is what we're looking for here with number 8. A is in what relationship to D? Well, take a look at how A is on the left of D. It's further this way, and so A is less than D. I tried 8, now you try 9 through 11. Come back to check your work and do 12 with me. 9. E is in what relationship to D? We'll take a look. E is closer to the greater than arrow than D is. So E is greater than D. 10. C is in what relationship to A? Well, C is closer to the greater than side than A is, so C is greater than A. And finally, B is in what relationship to E? Well, B's over here, closer to the less than arrow than E is, so B is less than E. Now, don't panic about these examples. This is not like what you'll see on the GED. This is just something I want to do with you guys to kind of build those reasoning skills. So it says use the given information to describe the possible values. 12. Zach is relieved because he knows that after he gets paid this week, he'll have more than enough to pay his rent. If he gets paid $612 each week and his rent is $1,080, what can we assume is true about his current balance? So we know that at the end of the week, he's going to have at least, no, more than that. It says he'll have more than enough to pay his rent, right? So he's going to end up with more than 1,080. And you don't have to write it this way. This is just me being too lazy to spell more than. But that's after he gets paid. We don't know how much he has right now, but we can assume that there's at least a certain amount based on that 612, right? That 612 he hasn't been paid yet. Well, it's not in his account. So let's take it out of the 1,080. So 1,080 minus 612 gives us 468. So if he's going to have more than 1,080 after he gets paid, he must have more than 468 right now because we're not counting what he's going to get paid. So what can we assume about his current balance? He has more than 468. And you might want to also say he has less than a certain amount since you knew he was worried about not having enough to pay his rent. Like, oh, he has to have less than that right now. That is probably a good inference. Like we could logically assume that's true, but since it didn't say it, we won't specifically say that. But he has more than 468. Now you can try the next 3 by yourself if you'd like, kind of reason through it and puzzle through it, but we can do it together as well. 13, a certain company charges a flat rate to ship boxes that weigh up to 20 pounds. Kate is shipping math workbooks that each weigh 1.25 pounds or 1.25 pounds. What do we know about the number of workbooks she can fit in a box charged at the flat rate? Let's see. The box can weigh up to 20 pounds. So that means it's okay for it to be less than 20 pounds or for it to equal 20 pounds. But we're not talking pounds. They want us to figure out the number of workbooks she can fit in a box charged at the flat rate. Well, let's see. Each one of the workbooks weighs the same amount. It weighs 1.25 pounds. So I want to take that 20 and divide it into equal sized pieces if each one weighs the same amount. So I'm going to divide by 1.25. So 20 divided by 1.25. And I see that I will be able to do less than or equal to 16 books in a box and not go over that 20-pound limit. Nice. And again, you don't have to use the symbol. You can say she can ship less than or equal to 16 books. Or you could say she could ship 16 or less books. 14, the starting pay for workers at Coffee Go-Go is $14.45 per hour. If there are always 4 or more workers scheduled on a weekday morning, what can we assume about the hourly cost of labor at Coffee Go-Go? So the starting pay for workers is $14.45. That means that they could make $14.45 or they could make more. But we can also see there are always 4 or more workers scheduled on a weekday morning. So there's at least 4 again, so 4 or more. So the very least we could pay, we better put greater than or equal to, because maybe they just have 4 at just $14.45 per hour. But 4 times 14.45 is $57.80. So the very least that they could pay is $57.80, but honestly, they'll probably pay more than that per hour. So the least possible hourly labor rate is $57.80. 15, if Leslie will still owe her sister money after paying her back $550, what can we assume about how much she borrowed? Okay, she's still going to owe her sister money after paying her back $550. Oh, well, this one's, I feel like, the easiest. Maybe I should have put this one first. She definitely borrowed more than $550 if after paying the $550 back, she still owes her. All right, why did we finish with that one? I don't know. But hopefully that helped to give you some context about why we use less than, greater than symbols and why we might have inequalities. Here's some real life scenarios. Now let's apply it. Solve each inequality. 16, x plus 12 is less than 60. So just like we do with an equation, you can draw that line through your inequality symbol so you can tell the left-hand side from the right-hand side, and we can see that I don't have x alone here. I've got to get rid of this 12. Well, the 12 is adding with x, so I will subtract it. I can do whatever I want as long as I keep my balance. Now, we did learn a couple of times when the inequality sign flips, but now is not one of those times, not when we subtract. So adding and subtracting cancel. X is alone just like I wanted. Like I said, subtraction did not affect the inequality symbol, so I'll still have a less than, and 60 minus 12 is 48. So what would X have to be to make the original inequality true? Well, X would have to be anything less than 48. Done. All right, I did 16. I'd like you to try 17 and 18. Join me back to check your work and do 19 together because it's got a little trick. 17, x minus 12 is greater than or equal to 60. So once again, I can see here, x is not alone on its side of the inequality symbol. And so I will get rid of this 12. It's subtracting with x, so I will add it. And again, I can do whatever I want as long as I maintain a true relationship between the left and the right-hand sides. Subtracting 12 and adding 12 are opposites. They cancel. X alone, just like I wanted. Adding never, ever, ever affects the inequality symbol, so I'll still have a greater than or equal to, and 60 plus 12 is 72. So what would x have to be in order to make the inequality above true? X would have to be anything greater than or equal to 72. 18, 12x is greater than 60. Putting that line through my inequality symbol, I can see that there's a 12 hanging out with x. This time it's a multiplier, so I'll do the opposite. I'll divide on both sides to keep that same relationship. Multiplying by 12 and dividing by 12 are opposites. They cancel. X is alone just like I wanted. Dividing by a positive is not going to affect that inequality symbol. And so I still see a greater than sign. And 60 divided by 12 is 5. So what would x have to be in order to make that original inequality true? Anything larger than 5. 19, negative 12x is less than 60. So once again, dropping down my line through the inequality symbol, I can see that I have a negative 12 hanging out. Now, careful, don't add 12 here. Notice that that negative 12 is shoved up against x. It's multiplying with x. So if I want to take it away from x, I am going to have to divide by negative 12. Okay, if you want to break up the bonds between a number and a letter that are multiplying, you must divide. And divide by exactly what you want to get rid of. Make sure I see the same operation, same sign on the other side. Keep your balance. So multiplying by negative 12 and dividing by negative 12 are opposites. They cancel. X is alone just like I wanted, but careful. Oh my gosh, careful, careful. Did you notice? There's one of the times we flip our signs. If we multiply or divide by a negative, we flip our inequality symbol. And so I won't see less than anymore. I'm going to see greater than, and 60 divided by negative 12 is negative 5. So what would x have to be in order to make the original equation true? X could be anything greater than negative 5. So I did 19. You try 20 through 21. Join me back to check your answers and to work on 22 together. 20, x over 12, or another way to say it, x divided by 12 is less than or equal to 60. So don't freak out at the fraction, you guys. Remember that one way to think about a fraction is an act of division. So if x is being divided by 12, I can just get rid of my little fraction problem by multiplying by 12. And I'm doing myself a visual favor by lining that 12 up with the x so I can see that cancellation. And of course, I can multiply the left-hand side by 12 as long as I also multiply the right-hand side by 12. So multiplying and dividing by 12 are opposites. They cancel. X is alone just like I wanted. Yeah, I multiplied, but it was by a positive number, so it's not going to affect the inequality symbol. And 60 times 12 is 720. So what would x have to be in order to make the original inequality true? Anything less than or equal to 720 would do it. 21, x divided by negative 12 is greater than 60. So same thing, that negative 12 is dividing x. So if I want to get rid of it, I'm going to need to do the opposite of dividing. I'm going to need to multiply. Make sure you multiply by exactly what you want to get rid of. So negative 12. I can do whatever I want as long as I do it on both sides. Notice that I'm putting the negative 12 in parentheses this time, just so you can tell that it's multiplying and not subtracting. Multiplying by negative 12 and dividing by negative 12 are opposites. They cancel. X is alone just like I wanted. But did you notice? Oh my goodness. I multiplied by a negative number. It was a change I made to both sides. So I changed the relationship. So I am going to see that sign flip. It was greater than, now to be less than. And of course, we said 60 times 12 is 720. So 60 times negative 12 will be negative 720. So what would x have to be in order to make that original inequality true? X could have been anything less than 720. Number 22 through 29 just asks us to fill in the blank to make a true statement. Number 22, if Mako is shorter than Calvin, then Calvin is what? Then Mako. Well, what do we know to be true? Well, if Mako's short, then Calvin, he's tall. So Calvin must be taller than Mako. I did 22. You try 23 through 25 by yourself, and then join me back to check your answers and work on 26. 23, if Javier is older than Julie, then Julie is, oh, well, Javier's old, then Julie's young. Julie must be younger than Javier. If Zane has more money than Petra, oh, poor Petra, she's got less. If Felipe eats less than Chloe, then Chloe eats more than Felipe. Just trying to really get you in that habit of flipping it around. If you flip the order in life, it flips the relationship. Well, same thing in algebra. 26. If 1 is greater than x, guys, 1's the bigger number, then x is less than 1. I know I talk a lot of smack about those alligators, but this is one time when those alligators might help us. If that alligator mouth was eating the 1, that's the bigger number, then it doesn't matter which order I write that sentence in, we can see that that inequality symbol is still open towards the 1. I did number 26. You try 27 through 29. You can turn the video back on to check your work and join me at number 30. If -4 is less than or equal to y, then y, well, it must be greater than or equal to -4. I flipped the order, so I flipped the inequality symbol. If 6 is less than z, 6 is the smaller number, then z is the bigger number, so z must be greater than 6. Number, whoa, typo. You never saw that. If -5 is greater than or equal to t, then t must be less than or equal to -5, and I have no idea how it's related to 1. All right. Directions for 30 through 35 say solve. Express your final answer as an inequality with the variable on the left-hand side. So 30 says 60 is less than x plus 12. Putting that line through the inequality sign, we can see x on the other side. Well, that's fine. That's fine. Whether he's on the right or the left, I can still work to isolate him. There's only one thing to do here. It's get rid of that plus 12. And so I'll do the opposite. I'll subtract 12 on both sides. And let's see what our new equivalent inequality will be. 60 minus 12 is 48. Subtracting never affects the inequality symbol. Adding 12 and subtracting 12 are opposites. They cancel. X is alone, just like I wanted. This is true. This is right. This is solved. X is alone. However, it's not in the standard way we usually write it. We usually write it with the letter first and the number afterwards. And so therefore, if you put the bigger number where the smaller number was and the smaller number where the bigger number was, you'd better flip the inequality symbol. And so what would X have to be in order to make the original inequality true? X would have to be anything bigger than 48. I tried 30. Your turn to do 31 and 32. You can turn the video back on to check your work or just meet me at number 33. 31, 60 is greater than or equal to x minus 12. Put that line through that inequality symbol. I can see x over there on the right-hand side this time, but it's not alone. So I'm going to add 12 to both sides to get rid of that subtract 12. Subtracting 12 and adding 12 are opposites. They cancel. X is alone just like I wanted. Adding doesn't flip the inequality symbol. 60 plus 12 is 72. But now I want to write it in the normal order. I'll put the x first. And since I'm taking that smaller x and putting it there, now that's going to flip to a less than or equal to 72. So what would x have to be to make the original inequality true? X would have to be anything less than or equal to 72. 32. 60 is greater than 12x. Once again, we can see x is not alone. On his side of the inequality, there's a 12 multiplying, so I will divide it away, keeping my balance by doing the same thing on both sides. Multiplying and dividing by 12 are opposites. They cancel. X is alone just like I wanted. I didn't do anything to affect the inequality symbol, and 60 divided by 12 is 5. This is true, this is right, this is solved. However, I want to speak like a mathematician, so I'll flip the order. So if 5 is the larger number, then x is the lesser number. X is less than 5. I flip the left and right-hand side, then I flip the inequality symbol. So what would x have to be in order to make the original inequality true? It would have to be anything less than 5. 33, 60 is less than -12x. Now, there's a couple of different ways to tackle this. You have some freedom here, but I think I'm going to do it the way most students usually think to do it, because there's a couple of chances here for you to make a mistake. Putting that line through my inequality symbol, I can see x is not alone. There's a -12 hanging out. It's shoved up against x, so it's multiplying. So I will divide to get rid of it. Now, make sure you divide by exactly what you want to get rid of. Don't leave that negative hanging out. And then, of course, when you jump across that inequality symbol, make sure you use the same operation, same sign, same number. Now, careful. You just divided by a negative. You've got to flip the inequality symbol. Multiplying and dividing by -12 are opposites. They cancel. X is alone just like I wanted. I've got to flip that inequality symbol because I divided by a negative. So I had less than, now I'll have greater than. And 60 divided by -12 is -5. Now, I flipped it because I divided by a negative, but now I don't like this order. It's true, it's right, it's fine, just weird. And so instead of having the x on the right, I'm going to put it over to that left. -5 will come over here. And I flipped the sides. So I did both in the same problem. And so I'm going to see that symbol flip again. So it's not that it didn't flip, it's that it flipped twice. That tricks you guys a lot. What would x have to be to make the original inequality true? Well, anything smaller than -5. 34. 60 is less than or equal to x over 12. Don't let the fraction freak you out, guys. I can get rid of dividing by 12 by multiplying by 12. I can do whatever I want as long as I keep the relationship between the left and the right-hand side a true relationship. So 12 times 60 is 720. I haven't done anything to affect the inequality symbol. It's the same. Multiplying and dividing by 12 are opposites. They cancel. X is alone, just like I wanted. But this is a little weird. It's written in the opposite order I usually write it in. So I'll flip the left and the right-hand side. And of course, if I flip the left and the right-hand side, I must flip the inequality symbol. If 720 was the smaller number, X is the larger. So what would X have to be in order to make the original inequality true? X would have to be anything larger than or equal to 720. 35. 60 is greater than X divided by -12. Again, I don't want this X being divided by -12, so I'll get rid of it by multiplying by the same number, -12. I can do whatever I want as long as I do it to both sides. And also, if I know the consequences. -12 times 60 is -720. I multiplied by a negative. If you multiply or divide by a negative, you negate the inequality. You change the signs of both sides. You just put the big number where the small number was and the small number where the big number was. Make sure you flip your inequality symbol. I had a greater than, I'll now have a less than. Multiplying by -12 and dividing by -12 are opposites. They cancel. X is alone just like I wanted, and this is true. This is solved, but it's a little weird. So I'll put the X on the left-hand side. I'll put the number on the right-hand side. And since I took the bigger number, moved it where the smaller number was, and vice versa, I must also flip my symbol. And once again, I see that symbol flipping twice in this case. X is greater than -720. So nothing new here, guys. We're just going to put these two new concepts together with some multi-steps. 36. 2m minus 1 is less than 7. Don't let yourself get overwhelmed in symbols. Put that line through your inequality. Notice you have two numbers to get rid of this time, a 1 and a 2. When we're solving, we work the order of operations backwards. So move anything that's adding or subtracting with m first. So the 1 is subtracting from m. I will add 1 to get rid of it. And I will keep my balance. What is my new equivalent inequality? Well, subtracting 1 and adding 1 are opposites. They cancel. I've got 2m here on the left. Adding does not affect inequality symbols. And 7 plus 1 is 8. Not done yet because the letter's not alone. That 2 is multiplying. I'll divide to get rid of it. I'll keep my balance, keep those guys in the same relationship. Multiplying and dividing by 2 are opposites. They cancel. M's alone. I haven't done anything to affect that inequality symbol. And 8 divided by 2 is 4. So what would m have to be to make the original inequality true? M would have to be anything less than 4. 37, -2m minus 1 is less than 7. Very similar to the last one. Once again, I can see I have two numbers to get rid of in order to get m alone. Since I'm solving, I'm going to move anything adding or subtracting first. So I will take away the -1 by adding 1 to both sides. What will my new equivalent inequality be? Well, subtracting 1 and adding 1 are opposites. They cancel. I've got -2m on the left-hand side. Adding does not affect the inequality symbol, so I'll have the same one. I'll still have a less than. 7 plus 1 is 8. M is not yet alone. I have to keep solving in order to get M alone. It has a -2 shoved up against it, so it's multiplying, so I will do the opposite. I will divide by -2. I can do whatever I want as long as I do it to both sides, and I know the consequence. Dividing by a negative flips the inequality symbol. Multiplying and dividing by -2 cancel their opposites. M's alone just like I wanted. As I said, I divided by a negative, so instead of less than, I'll have greater than, and 8 divided by -2 is -4. So what would M have to be to make the original inequality true? Anything bigger than -4 will do it. 38. 4p plus 13 is greater than or equal to 1. Visually break this inequality into its two expressions. I can see I have a 4 and a 13 hanging out. I'll work the order of operations backwards, moving anything adding or subtracting first, using opposites on both sides. My new equivalent inequality, well, let's see, adding 13 and subtracting 13 are opposites, they cancel. There's just 4p on that left-hand side. Subtracting does not affect the inequality symbol, it won't change. And do this in your calculator if you need to. You probably should, just do it in your calculator since we're focused on the algebra. 1 minus 13 is -12. It's not that you can't combine everything, guys. It's just that if you try to do it too early, you'll get lost in symbols. So P is not yet alone, and so I'm not done solving. It has a 4 multiplying with it, so I'll divide away that 4. And I'll keep my relationship the same between the two sides by doing the exact same thing on the other expression. Multiplying and dividing by 4 are opposites, they cancel. P's alone, just like I wanted. Dividing by a positive won't affect the inequality symbol, so I still see greater than or equal to. And -12 divided by 4 is -3. And you say, I divided with a negative. It wasn't a change you made, and so you did not flip the sign. So what would P have to be in order to make the original inequality true? Well, it would have to be anything bigger than or equal to -3. 39. 1 is greater than or equal to 4p plus 13. Couple of ways to tackle this, but I think I will isolate first. So looking at this, P is not alone. It has a 4 and a 13 hanging out. If I want to get it alone, I'm going to use opposites on both sides, working even the order of operations backwards. Adding 13 and subtracting 13 are opposites, they cancel. I've got 4p on my right-hand side. Subtracting does not affect the inequality symbol. I'll have the same one. And 1 minus 13 is -12. P is not alone yet. It has a 4 multiplying. I'll divide it away, keeping those two expressions in the same relationship by doing the same thing on the other expression. Multiplying by 4 and dividing by 4 are opposites, they cancel. P is alone just like I wanted. Dividing by a positive doesn't affect the inequality symbol, so there it is. And -12 divided by 4 is -3. Now this is true and good and solved. However, it's a little weird. Let's flip it so the letter comes first. So I'll have P coming first, -3 coming second. And since I put the big number where the small number goes and the small number where the big number goes, I will flip my inequality symbol as well. So what would P have to be in order to make the original inequality true? Well, anything less than or equal to -3. 40, -9 times the quantity of t minus 7 is greater than 108. Couple of different ways to go here, but I think I'll follow our lovely simplify before we solve wisdom principle and pass out this -9 to this grouping here. I know how to multiply with a grouping. So -9 times t is -9t, and -9 times -7. Don't miss either one of those negatives as I think of them when I'm multiplying, but that will give me +63. Now, yes, I did multiply by a negative, but it wasn't a change I made. It was already in the problem, and so you did not change the relationship. So keep the symbol the same, and I'll still have 108. Great. Now I can work to get t by itself. I'm going to get rid of anything adding or subtracting first, doing it on both sides. Adding 63 and subtracting 63 are opposites, they cancel. I've got -9t on this side. Subtracting does not affect the inequality symbol. I'll have the same one. 108 minus 63 is 45. T is not alone. It has this -9 multiplying it. I'll divide it away, and I will understand the consequences of dividing by a negative. Yes, -9 multiplying and -9 dividing are opposites, they cancel. So yes, t is alone just like I wanted. But because I divided by a negative, I negated my inequality. It will change the symbol. What was greater than will become less than. And 45 divided by -9 is -5. So what would t have to be to make the original inequality true? Anything less than -5. 41. 121 is less than or equal to 4p plus 7p. Look at that. Wisdom principle number 1 says simplify before you solve if possible. And I do see some simplifying I can do. On that right-hand side, there's some like terms I can combine. If I have 4 p's and then I get another 7 p's, I'll have a total of 11 p's. Simplifying never affects the inequality symbol. I'll still have a 121 on that side. P is not alone. It's got an 11 multiplying it. I will divide it away, keeping my balance. Multiplying and dividing by 11 are opposites. They cancel. P is alone just like I wanted. I divided by a positive. That's not going to flip the symbol. And 121 divided by 11 is 11. Now, this is true, right, and solved. Just a little weird because we like the letter first and the number second. And so I'm going to flip the order of those. And so I must also flip the sign. What was originally less than or equal to is now greater than or equal to. So P would have to be anything greater than or equal to 11 in order to make the original inequality true. Great work, you guys. I'm super proud of you. Thank you for sticking with me. Now I want you to go on to do your beginning level practice, right? That is what we do next. You need to take it from the stage where you do it with me prompting you to where you do it prompting yourself. Now, as you do that, don't forget your script. You have to take the things I would say and you have to start saying them to yourself. So remember that you're going to examine each side separately. Can you simplify? You're going to get the letters to the same side, preferably the left. This should sound familiar to you. These are the wisdom principles. And you should get the letter alone. But then remember that some actions have consequences. If you flip the relationship, you flip the sign. So that means if you multiply or divide both sides by a negative, flip the sign. Or if you do-si-do the order of the expressions, you put the left on the right and the right on the left. Then you've put the big number where the little number was and the little number where the big number was. So you must flip the sign. All right, you guys, I am so proud of you. You are doing hard work. This is the very last lesson. And from here on out, it's all review. All right, you guys, happy learning.